SpaceX has officially confirmed a bold shift. Starship's next recovery phase will happen at sea. Facing limits with the Mechazilla Tower and a growing launch schedule, Elon Musk's team is now developing a powerful ocean-based landing system for the Super Heavy booster. It's a practical, data-driven move that could redefine rocket reusability and global launch logistics. Let's dive right in. When Elon Musk first introduced the idea of catching a 70-meter rocket midair using giant steel arms, the world called it madness. But then, SpaceX did it. The Mechazilla Tower at Boca Chica turned science fiction into engineering fact. It caught boosters that once would have been lost forever. But here's the twist. SpaceX isn't stopping there. They've realized that to make Starship fully reusable and to support dozens of flights every year, the system must evolve. The truth is, Mechazilla alone can't handle the scale that's coming. And that's why SpaceX is quietly building its next leap forward. Ocean-based landings for the world's largest rocket. Landing a rocket on the ocean isn't new. SpaceX perfected it with Falcon 9. But scaling that system up for Starship, a vehicle more than twice as wide and 10 times heavier, changes everything. Mechazilla is powerful, but it's fixed to the ground. It can only handle a limited number of launches from one site. SpaceX's vision, however, demands constant launches, as frequent as air traffic. Even if they build more towers, launch pads still face strict safety zones, noise limits, and weather constraints. By moving recoveries to the ocean, SpaceX gains something priceless: freedom. Freedom from local government restrictions, freedom from congested schedules, freedom to launch and land from anywhere without disrupting operations on land. It's not a publicity stunt. It's a strategic move, a solution born from data, not drama. But turning the ocean into a launch pad isn't simple. The Falcon 9 drone ships, Of Course I Still Love You, a shortfall of gravitas, just read the instructions, are engineering marvels. But they were designed for rockets that weigh 25 tons empty. Starship's Super Heavy booster weighs more than 230 tons and generates 7,500 tons of thrust. That's 10 times the force. To manage that, SpaceX is designing a new generation of drone ships, massive steel platforms over 120 meters long and 80 meters wide. They'll feature heat-resistant decks, reinforced foundations, and an advanced water deluge system capable of pumping over 1,000 gallons per minute beneath the surface to handle the extreme heat from methane-fueled Raptor engines. These engines burn cleaner and hotter than Falcon 9's kerosene Merlins, reaching temperatures above 3,400 degrees Celsius. That means even a slight misfire could melt steel if the surface isn't cooled continuously. Everything from deck materials to the clamps that secure the rocket has to perform flawlessly under conditions that no company has ever tested at the scale. During a Falcon 9 landing, the booster adjusts its position using grid fins and a single engine. It slows to about 2 meters per second before gently touching down. The drone ship's thrusters keep it still within 3 meters of its target spot. For Starship, that precision isn't enough. The margin of error must shrink to less than 2 meters because the booster's 9-meter diameter leaves almost no room for drift. A 1-meter offset could mean disaster. To achieve that, SpaceX is upgrading its thruster system with 2,000 horsepower electric motors, capable of micro-correcting in real time, even in rough seas. Each movement, each gust, each wave must be predicted and countered instantly. It's like landing a skyscraper on a moving platform in the middle of the ocean. Here's what surprises most people. Starship won't have landing legs. Musk's team realized legs add unnecessary weight and reduce payload capacity. Instead, they've developed 4 structural hardpoints on the booster. When Super Heavy lands, these points lock into mechanical clamps built directly into the ship's deck. The moment the rocket touches down, within 5 seconds, those clamps engage, locking it firmly into place before any motion from waves can destabilize it. This design eliminates fragile landing gear, shortens recovery time, and increases safety. Once secured, crews can refuel and inspect the booster directly at sea, then either tow it back or launch it again offshore. The decision to move recoveries offshore didn't come out of nowhere. It's rooted in years of conflict between innovation and regulation. Back when SpaceX was expanding in California, the company faced endless delays, permits, taxes, environmental reviews. Musk often clashed with local officials who, in his view, prioritized bureaucracy over progress. Then came COVID-19 lockdowns. When operations were shut down, Musk had enough. He publicly criticized California's leadership and shifted his focus to Texas and Florida. But even there, new challenges arose: noise complaints, environmental lawsuits, and launch restrictions. That's when the ocean became not just an idea, but a necessity. Offshore operations mean no residential zones, no land ownership disputes, no noise boundaries. SpaceX can run tests, make modifications, and launch at its own pace, uninterrupted. Yet this plan is far from easy. Engineers must solve dozens of technical hurdles. Wave stability. Ocean swells can shift platforms by centimeters every second, enough to ruin a precision landing. Salt corrosion. Even stainless steel degrades under constant exposure to seawater and heat. GPS reliability. Magnetic storms and atmospheric distortion can interfere with positioning accuracy. Each of these challenges requires innovation. SpaceX is reportedly testing adaptive thrusters and AI-based stabilization systems that can predict wave motion seconds ahead, allowing the ship to counteract movement automatically. It's not just a landing pad, it's a living machine designed to think, move, and react in real time. Leaked FAA filings show SpaceX has proposed landing zones in both the Pacific and Indian Oceans, depending on flight trajectory. These documents confirm the company is actively developing recovery protocols for ocean-based Starship missions. While these operations haven't started yet, the groundwork is clear. Starship's 10th test flight has already validated critical systems like entry stability and engine throttling. Flight 11, expected in mid-October 2025, will test new telemetry software designed for marine recovery environments. It's not hype, it's the next phase in an actual engineering roadmap. SpaceX's end goal is simple: launch, land, refuel, and repeat. Just like commercial aviation, rockets must eventually operate on rapid, predictable cycles. The ocean landing plan isn't just about convenience, it's about scalability. Imagine a future where one Starship launches cargo, another delivers satellites, and a third heads to the moon, all in the same week. Ocean platforms make that schedule possible. By distributing operations across multiple sea-based sites, SpaceX can achieve a continuous global launch rhythm, something no space agency has ever done. At first, the cost seems massive. Each new platform could exceed $300 million to build and equip. But in the long run, SpaceX saves far more. Every reused booster saves tens of millions in manufacturing costs and months in production time. Musk's philosophy remains consistent: spend heavily on innovation today to eliminate waste tomorrow. It's the same mindset that turned Falcon 9 reusability from a crazy idea into an industry standard. There's another layer few are talking about. By mastering ocean-based recovery, SpaceX effectively creates mobile spaceports, capable of operating outside national borders. This could allow global operations, quicker response times, and potentially commercial or defense partnerships where fixed launch sites aren't feasible. Some analysts even suggest this move could open the door to rapid point-to-point travel on Earth, using Starship to connect continents in under an hour. Whether that's next decade or next century, this infrastructure lays the foundation. As always, the announcement has divided opinions. Supporters call it a brilliant solution to a scaling problem, a move that redefines what reusability means. Skeptics warn that ocean recovery introduces too many variables. But that debate is exactly what fuels progress. Every major breakthrough, from Falcon 9's first landing to Starlink's global coverage, started as something too risky. SpaceX has built its legacy on doing the things others won't even attempt. This ocean recovery project is the next chapter in that story. According to internal timelines, SpaceX aims to complete the first full-scale platform by 2026. 2 decommissioned oil rigs, Phobos and Deimos, have already been purchased and are being converted into floating Starship ports. If successful, These rigs could serve as prototypes for future global bases, one in the Atlantic, one in the Pacific. And once those are operational, the company could technically perform Starship launches anywhere there's deep water access. That means faster turnaround, higher safety margins, and unlimited scalability. This isn't just about where rockets land. It's about how humanity moves forward. By pushing recovery offshore, SpaceX is quietly transforming spaceflight from a government-controlled project into a truly global transportation network. Every landing at sea brings the company one step closer to daily launches, orbital refueling, and interplanetary travel. It's not science fiction anymore. It's logistics, precision, and relentless iteration. And for anyone watching closely, it's proof that the future of spaceflight might not start in the sky, but on the ocean. And this is exactly why SpaceX's ocean landing plan is more than a bold experiment. It's the next step toward a fully reusable, scalable spaceflight system. By taking recovery to the sea, SpaceX isn't escaping limits. It's rewriting them. What this means is simple. Every successful ocean landing brings us closer to affordable, frequent missions to orbit, the moon, and eventually Mars. The first real test could begin as soon as 2026, and when that happens, the entire launch industry will have to catch up. And this is just the beginning. The era of rockets returning from the ocean is about to redefine human access to space. What do you think? Is the ocean the smartest path forward for Starship? Drop your thoughts below. We read every comment. This is Space Hub, where we break down space breakthroughs that shape our future. If you found value in today's video, hit like, share it with a friend, subscribe, and turn on the bell so you never miss what's next in space. The future is rising, and it starts at sea.